Hello, and let's start with 0 of the polynomial. So first, before we start with our topic, let's understand what do you mean by 0 of the polynomial. So suppose imagine I have a polynomial like 2x minus 2. Alright, this is my polynomial. It's a linear polynomial, obviously. I'm going to write it p of x is equal to 2x minus 2. So what do you mean by this x over here? This x is something like in what terms is the equation written? Like suppose if it is p of x, so it's going to be 2x minus 2. If I write it as p of a, so it means I'm going to write this equation in terms of a, like such as 2a times 2. Basically, wherever is the variable, I'm going to change that place. So if it is p of t, so it's going to be 2t minus 2. Alright, so what do you think it will be if I just p of g? Tell me. Pause this video and tell me what is it going to be. Yes, it's going to be 2g minus 2. Alright, so next part. Now, what is a 0 of a polynomial? So basically, 0 of a polynomial is a number which I'm going to substitute here at the place of x, and the answer, when I calculate it, it's a number, and when I calculate it, it should give me a 0. Such as 2 into what minus 2 will give me a 0. What should I keep the value of x that I substitute here and I multiply with the 2 and then subtract with this other 2, so I get a 0. Yeah, it could be 1. It could be 1. Let me write the equation in terms of 1. So it's going to be 2 into 1. Alright, I'm going to put this in the bracket. 2 into 1 minus 2. So what is 2 times 1? It's a 2. And then 2 minus 2 is a 0. So we are going to say that 1 is the 0 of a polynomial. 0 of polynomial 2x minus 2. If I were to substitute p of 2, if I write it like this, 2p of 2, which is something like 2 into 2 minus 2, which is like 4 minus 2, this is not giving me a 0. So we are going to say p of 2 is not the 0 of a polynomial. P of 1, however, it is, because it gave me the answer 0. So we are going to, so this is what the whole concept behind 0 of a polynomial is. You know, we have to, the number that we substitute in the equation in the polynomial, if it turns out to be a 0, then that number is called 0 of a polynomial. Let's move on with some examples. Check whether minus 2 and 2 are zeros of the polynomial. So basically, we have to substitute minus 2 at this place, and we are going to check if it's a polynomial or not. Pause this video and do it by yourself, and then see, and then we'll compare our answers. Alright, so over here, if we have substituted, our polynomial is p of x equals to x plus 2, and then we have to check if minus 2 and 2 are the zeros of the polynomial. So p of minus 2 gives me minus 2 plus 2, and yes, we got a 0 for this. But however, for p of 2, we are not getting a 0. So we are going to say that p of minus 2 is the 0 of the polynomial, but p of 2 is not. Alright, I hope that this was clear with you. Let's check for this one. Find the 0 of the polynomial p of x equals to 2x plus 1. So basically, we have to come up with some number that I can substitute here, and then that will give me a 0. Can you think of a number? Pause this video and try it out. Okay, so sometimes there are times that we just don't know what to do. We can't do trial and error method all the time to find what is a 0. Maybe we don't have time for that. So there is an easy hack for you that you can find the 0. So this is our linear polynomial, yes, 2x plus 1. So we have p of x equals to 2x plus 1. So I need the answer to be a 0, right? So let me just manifest a 0. 2x plus 1 equals to 0. Let me just take 1 to the other side. So it becomes 2x equals to 0 minus 1, which is 2x equals to minus 1. Now, what's the next step? This is 2x, which is bounded by 2x in the terms of multiplication. So I'm just going to take it to the other side. So the opposite of multiplication is division. So I'm going to get x equals to minus 1 by 2. So this is my 0. If I substitute in this equation with minus 1 by 2, then I'll get a 0. So let's try that. Let's verify our answer. P of minus 1 by 2 gives us 2 into minus 1 by 2 plus 1. Let me put this in the bracket. The 2 and 2 can get cancelled and we are left with minus 1 plus 1, and that is a 0. So yes, we are going to say that P of minus 1 by 2 is a 0 of a polynomial. No way we could come up with guess this number minus 1 by 2. Maybe we could guess 1, 2, anything. We are just going to be trying and we might not get it. But then the best way, if it's a linear polynomial, you can use this hack and you can find out what's a 0. Alright? Now verify whether 2 and 0s are the polynomial of the zeros of the polynomial x squared minus 2x. So our polynomial is x squared minus 2x. So let's verify if 2 and 0. So quickly we're just going to write p of 2, which is 2 squared minus 2 into 2. So 2 squares are 4 and then minus 4, and that's a 0. So yes, p of 2 is the 0 of the polynomial. Let's check with p of 0, which gives us 0 squared minus 2 into 0. So that's a 0, 0. So that's a 0. So yes, p of 0 and p of 2 both are the zeros of the polynomial x squared minus 2x. So what are the conclusions that we have drawn from this? That a 0 of the polynomial is not always a 0. Means p of 1 can be the 0 of the polynomial, p of minus 1 by 2 can be the 0 of the polynomial, p of 2 can be the 0 of the polynomial, but it does not mean that since it's a 0, then p of 0 is always going to be the polynomial. No, that's not compulsory. 0 may be the 0 of the polynomial. Sometimes, like in this case over here, like in the old one over here, we got p of 0 as a 0. So yes, sometimes p of 0 is a 0 of the polynomial. And every linear polynomial has only one and only one 0, such as the hack that I just told you here, that how to find. Here we find just 1 0. So linear polynomial has only 1 0. It does not have more than that. Means this equation has only this as a 0 and no other number. Like how in this equation, it's a quadratic equation, we had 2 zeros. But in linear polynomial, we have just 1. And a polynomial can have more than 1 0. It depends on what kind of polynomial it is. Alright, so I hope this video was clear with you, and next video we're going to start with our exercise. See you then. Bye.